Hi everyone, Krishna this side. In this video, I'll be covering this LeetCode problem 2311, longest binary subsequence less than or equals to k. So let's see what problem is basically saying. You are given a binary string s and a positive integer k. Return the length of the longest subsequence of s that makes a binary number less than or equals to k. Okay. The subsequence can contain leading zeros. Empty string is considered to be equals to 0. And a subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining characters. Okay, so a string has been given, so we have to derive another subsequence from this string, such that when we sum it up, the binary number, whatever the value that we get, it should be less than or equals to this k. Okay, so what it is basically trying to say, let me connect the screen and I'll explain you. So I hope the screen is up, and let's say this is the string that we have given, and k value is basically equals to 5. So this is binary formation that is been clear. So if I want to convert this binary representation into the decimal form, so what we do basically here, it's 2 to the power of 0, 2 to the power of 1, 2, 3, 4, 5, 6. This way we keep on having the values, right? And what we do basically, whatever the value here, it is been there. We simply multiply with this above values, right? So 0 into 2 to the power of 0 plus 1 into 2 to the power of 1 plus 0 into, again here it is 2 to the power of 2. So this will keep on going. At last it is like 1 into 2 to the power of 6. Okay, these are the values that we have. When we sum them up, okay, entire values, these values, when we sum them up, whatever the value that we get, it is going to be in a form of decimal. Okay, this 5 is basically in a form of decimal, correct? So yes, that is the clarity that we have. If I want to convert this 5 into the binary, so what we do is basically we will keep on dividing it. That's what I am basically doing. So whatever the remainder that we get here, it is 2. Again, when we divide, 0 is the remainder that we get and 1 is remain. Okay, we cannot divide further this one. So whatever the values that we are getting, that is going to be the binary representation of 5. Okay, so this way, whatever this value that we got generated, we simply had divided here whatever the answer that we get, right? We simply had divided it and we have collected all of them from the downside to the up. So that's why it is like 2 to the power of 0. So 0th index, whatever is been there, that basically gets represented at the last. So that's why we basically multiply them in reverse order. Okay, so that is the basic idea that I have given, like how the binary number and decimal numbers basically get converted. So now we have to make sure that whatever the values that we are considering a subsequence from this string, okay, it should be less than or equals to this 5's value. How we can do it? See, if I start from the start point, okay, from the starting, if I start reading this string from the starting, I am not sure that whatever this value that we get, whether this value is going to be matchable with this 5 or not. Okay, whether this particular one we have to consider it or not. Why? See, if I calculated this to the power of 6 into 1, let us suppose 32 is the answer that I do get. Probably, I'm not sure about it. No, sorry, it's going to be 64, I guess. Okay, so 64 is the value that we get from this one. Okay, let us suppose k value is basically equals to 65. So first thing that comes in our mind is, okay, we can consider it. Okay, this whatever the value of 1 is basically 64 we are getting, and 65 is something what we are looking for. Okay, instead of 5, if it has been given 65, the first question comes in mind is, okay, 64 is basically less than 65, we can consider this one. But what if again there are few ones that are there? So at any point in time, one is the value that one is basically appearing. What we are doing, we are basically multiplying its power. Here it is like 2 to the power of 3 into 1. So this basically equals to 8. So again 64 plus 8 is going to be it's going to be 72, correct? So 72 is the value that we are getting, but it is now actually greater than this 65. Okay, so is it really worth to consider this one? Okay, is it really worth to consider this one? Because again we are getting ones in the future. Okay, these ones are basically making this value bigger continuously, so it is really difficult to track from this starting point and get the sum. Okay, so what we will do is, instead of starting from this first index, we will start from the last index, and whatever the answer that we are getting, it should be, we will simply comparing it with this current 5. So what we will do currently, we will start from the back. That is clarity that we got. Okay, so let me clean this up, whatever the mess that I have created right over here. So now when we start from the back, so it is like 0. 0 is the value that we have. 0 into 2 to the power of 0 is basically 0. So 0 is basically less than or equals to 5. Okay, that is clarity. So yes, we are okay with this 0. So any zeros that we are getting, it is basically said that leading zeros are, we are okay with the leading zeros. So any zeros that we are getting, we can simply consider them. Okay, that is the clarity that we got. Okay, so zeros, we never have any problem with the zero. So we will keep on counting zeros wherever it is basically getting appeared. Okay, the moment we get one, their issue actually rises. So what we do whenever we get one, 2 into 2 to the power of 1, that is the value that we get. So what this basically represent, it is basically 2. So we will just simply compare it with the 5. So whether this 5 and 2 are actually satisfying the given condition. Okay, so 2 is actually less than 5, so it is acceptable. So this one is basically acceptable. Okay, so we will consider this one. So the first idea now here comes in our mind is wherever the one basically getting appeared, we will simply multiply it with this to the power of whatever the value that we get. Okay, so it is basically index. Ultimately whatever this to the power of 0, 1, 2, 3, these values we are considering, right? Those are basically index we can consider. It is zeroth index, although the zeroth index for the string is this, but we can consider this in a reverse order as well. Whatever the string length, let us suppose if length is n, so this is basically last index. Let us suppose it is ith index, I minus 1 if we do. So let us suppose that this is like 0, 1, 2, 3, 4, 5, 6. I is basically 6 here in this case. N is basically 7. 7 length minus 6 minus 1 if we do, 0 is the value that we get. So that is how we can derive this index. Okay, so whatever the I value we are starting from the back, we will derive this index. Okay, in this fashion. So n minus I minus 1 if we do, so the value is basically what we will going to get. Okay, the moment we get the index value, we will simply multiply it with 2, only if the one is something what we notice at any point in time. If strings value is basically equals to 1, we will simply multiply it with 2 to the power of whatever the I index that we derive, and we will keep on checking that whether its value is actually equals to or less than equals to this case value, and that way we will get the answer. Here another thing is, whenever we multiply it, whatever the sum we got in the future, that sum should basically consider with the next value. What I'm trying to say, now here the 2 is the answer that we got. Okay, so again here it is like 0, so we can simply consider this 0, there is no problem in that one. Again 1 is the value that we get, so its value is basically 2 to the power of 3 into 1, basically it is 8, correct? So 8 and the previous value was basically 2, so in total so far 10 is the answer that we get it. So whatever this particular binary representation if we consider, it is basically 10. So now 10 is basically greater than the 5, the value that we have given. Okay, so the moment we realize that, we will stop counting ones, and we can keep on counting or consider all the ones that are there available into the string. So that way whatever the string that we have generated, it should basically satisfy the given conditions. Okay, that is how we can solve this particular one. Let me write down the code, and after writing the code I'll explain you what basically we have saw right over here, and then again we will discuss about this one. Okay, so let's start writing the code. In one single pass only we can write the code. So the first thing that I'll get is here from this one, let's get the length, s dot length. Okay, we'll run a for loop for int I equals from the back we will start, so n minus 1. Okay, because we don't want to go out of bound. And first thing that we will do is we will check that if s dot char at I, if it is equals to 0. Okay, if it is equals to 0, we will simply all consider all the zeros, because it can contain leading zeros as well, so we do not have any worry. So we basically have to return the maximum length that we can get it. Okay, so simply we can consider the 0. So count, let us create a count variable, and we will increment its value, and count equals to 0, and count is basically got incremented. Else, in the else condition, the first thing that we will do is we will create another sum variable right outside here, sum equals to 0, and in this sum, okay, in this particular sum I'll add this whatever the value of here at the current index, whatever the value that is there. Okay, if it is 1, then only we are entering into this else condition, so we have to simply get the 2 to the power of that particular index. So how we derive the index? Int idx equals to whatever the n value that we have, n minus 1 minus I, if we do, the index value is something what we will get. Okay, so what we have done, 2 to the power of this index is the value that we will going to get it right over here. So what we do, math dot pow, so this will give us the power value, so 2 comma this idx, if we do, whatever the answer that we get, that is something what we will add it into the sum. Now the sum is basically got calculated so far, so we will simply check that if sum is basically less than or equals to this whatever the k value that is given. So if that is the case, we will simply increment the counter. That means that 1 is basically we are simply considering it. Okay, at any point in time if sum exceeds, so we actually do not want to consider this one. So that what we can do, we will create another boolean variable right over here. So simply I don't want to enter into this else consider at any point in time if sum basically exceeds the k value, because after that it will keep on going increasing. There is no stop for this sum, and there is no point in calculating again the this particular index and get the math.pow and all. Okay, so what we will do is basically we will create is valid one. Okay, let me name it as like this. It is basically true currently. Let's check if is valid one. Okay, in that case only we will enter into this condition at any point in time when sum is basically greater than this k value. There I simply make this is valid 1 to false. Okay, so that from there onwards we will not consider the one. Okay, this will be false and we are done. So simply this is the code that we have. Let me return this count. Okay, let's try to run this code and see if it is working fine. So the basic idea we have done is, okay, there is the error is valid. Let me copy this one. Let's paste this. It should be else if, right? So yeah, I guess that is the correct. And here also, let me copy this and paste it correctly. Let's try to see if it is working fine or not. Yeah, all the test cases are accepting. So what we are doing basically, we started simply from the back side. Okay, if 0 is the character that we see, we simply updated the counter. At any point in time, if 1 is there, so yes, we will try to get the index. How we get it? The length of string, and whatever the index we are at, let us suppose this is the 5th index. If length of string is basically 7, 7 minus 5 is basically 2, and I actually want the index right over here. What is the index? So it is basically going to be 1, correct? This is the 0th index, this is the first index. That way we are going on, right? So from the back we are going, so that first index is something I will get. So 2 to the power of 1 into 1 is something what we are doing. So 1 basically if the character is 1, then only we can enter into this one, right? And at any point in time 2 to the power of 1 into 1, the answer is basically going to be the same. So yes, I am not multiplying here with the 1, but whatever the value that 2 to the power of any index that we are getting, that is something what I'll keep on adding it into the sum. That way we will get the sum values so far how many ones that we have explored. Okay, so when we do that, sum is basically at any point in if sum is less than or equals to this k value, we will consider that one. So we will increment the count because that is the length we are stretching out. Okay, and if not, we will make this invalid. So from next onwards, at any point in time, if any one is the character one is basically getting appeared, we will simply ignore that one. Okay, so that way we will write down this code. Let me try to submit this and see if there are any errors. And this is like single pass. We have written the code in one go only. We have written the code. So instead of this mat.pow also we can use all the I mean there are by bit for bit manipulation we have few of the operators like so left shift operator and all that could be easily usable right over here at this place. But yes, if at all if you want to modify this one, right? So what we could have done here, we simply used this one left shift of idx. Okay, that way also it could have worked. But the problem here is the moment the index basically goes out of bound. Okay, the index at max we can consider only 31 index, sorry, 30 index, 31 index. If we go beyond that, this will go negative. Okay, so to avoid that condition, so we have to consider this into the long variable. So whatever the sum that I'm getting, I will be considering it into the long, and we can ignore this. Both basically same. So whatever the one left shift of index we do, it will basically keep on multiplying 2. Okay, so this is also valid. So if we again try to run this one, this could also work fine. So let's see if it is working fine, and even if we submit, this will also work. Okay, so this is the left shift operator. So whatever the index that we are, that many ones it basically gets shifted. That is ultimately means 2 to the power of that value is what we have seen it, right? So that's how it also basically works. Okay, that's all from this particular video. I hope you got the understanding. Thank you for watching this one. Bye bye.